Dear student, welcome back to the series of discussion on the topic thermal radiation. So today we will discuss about the black body radiation exchange. So please allow me to turn off our video so that the screen will be visible more. So for the discussion of black body radiation exchange, let us consider there are the two black body who is randomly oriented. See, this is the first black body and this is the second black body. This black body has area say AI and temperature Ti. It has area Aj and temperature Tj. Suppose the surface normal for the area I is Ni perpendicular to this surface which is oriented in this direction. Corresponding the surface normal for the surface J is in this direction. Let us say both are randomly oriented. So we are interested in determining what are the rate uh, of the radiation. That means the from this surface, from the surface, consider surface I. So the from the surface I, there will be the radiation coming out of this surface in every direction in hemispherical manner. Part of that radiation will be intercepted by another surface which is J, which is randomly oriented with respect to surface I. So we need to determine that rate of radiation which is leaving from the surface I and reaching to surface J or intercepted by surface J. Let us denote it as a Qij. Qij. That means radiation is coming out of I and reaching to the surface J. So these two orientation or the radiation, that is, there is the one concept shape factor that comes into the picture, and by the use of shape factor say Fij, which is defined as the ratio of the radiation that is intercepted by the J to the total radiation that is coming out of the surface I. So the ratio of these two, what is the radiation that is intercepted by surface J? That is Qij, and total radiation that is coming out of the surface I is Aiji. So the ratio between these two is nothing but the shape factor Ij. So Qij will become Qai and Fai multiplied by Fij Ji. So all the radiation here that is coming out of the surface I will be the radiosity, which is called as radiosity. So if we can say that Qij is the amount of radiation that is intercepted by surface J, which is coming out of surface I. So in the reverse manner, there will be the another rate that is the intercepted by surface J that is coming out of I. So that will be denoted by Qji. That means there will be the two terminology Qij and Qji. We have the Qij as Ai, Fij and Ji. So this Ji, since our body that we have considered here is black body, so we know that in the case of black body, the radiosity is equal to the radiation emitted by that black body or emissive power of the black body. So for the black body, J is equal to EB. J is the radiosity and EB is the emissive power. So for the black body, we can write in place of Ji, we can replace it by the EBI. So Qij will become AI Fij EVI. In the similar fashion, we can define Qji, that is Aj Fji EVj. So if we can determine the what is the net energy exchange, then we can take the difference. The first difference between Qij and Qji. So that difference will give the net radiative exchange between the surface I and surface J. The net, that because the part of energy is coming out from the I and intercepted by the J. In the similar fashion, the part of energy intercepted by J, that is coming out from the I. So the difference between these two will give the net radiative exchange between the two surfaces, and it is denoted by Qij. So Qij is Qi to J minus Qj to I. We have the formula for both. Therefore, we can substitute the value for Qij as Qij will become the Ai Fij Evi minus Aj Fji Evj. So we have from the reciprocity theorem, we can write down instead of Aj Fji, which must be equal to Ai Fij. So this is the reciprocity theorem. So by the use of reciprocity theorem, we can replace Aj Fji by Ai Fij, and we take the common out of these two terms, then we will get Ai Fij Evi minus Evj. Now EVI, we know that its definition is, it is defined as sigma into Ti to the power 4 and EVj as sigma into Tj to the power 4. So Qij will become Ai Fij sigma Ti4 minus Tj4. So we got an expression, the resultant expression between the surfaces I and J. So what does it signify? It is used to evaluate the net radiation between the surfaces. That means that surfaces should be the black surfaces and form an enclosure. So this equation, which is Qij is equal to Ai Fij sigma Ti to the power 4 minus Tj to the power 4. What is its significance that we learned is it provides the net rate. That means the net rate at which radiation leaving from the surface I and it is reaching out to the surface J. Means what? The radiation, that rate of the radiation which the surface J gains, how? By the interaction of the surfaces I. That means it provides the net rate at which radiation leaves the surface I as a result of its interaction with J. जब surface I surface J के साथ interact होता है उस समय का net rate देता है. Similarly, that must be equal to क्या? The rate at which J gains radiation due to its interaction with I, and it is used to evaluate the net radiation heat transfer from any surface in an enclosure of black surfaces. So here the interaction where between these two surfaces, That means the interaction where from the surfaces I to surfaces J. The interaction of surface I can have simultaneously with n surfaces. That means the radiosity or the radiation that is coming out of the surface I can be intercepted simultaneously by n surfaces. In that cases, in that cases, how we can write down? So the net surfaces that is coming out of the qi, that will be the qi, that is intercepted by the different surfaces. Say it is j surfaces, and that may be n type of surfaces, so it will vary the j from 1 to n. That means the first interaction, say the surfaces j1, then second j2, then third j3. So one by one, with the one surfaces, the interaction, the energy interaction will be this much: ai fij sigma ti4 minus tj4. Now for the second surfaces, it will become ai fij sigma ti to the power 4 minus tj2 to the power 4. So in this way, after summation for all that surface interaction, we can get the net rate transfer of radiation from the surface I. If we are interested to determine the flux, then by dividing by the surface area AI, we can have the net radiative fluxes. So in this way, we learned the radiation interaction between the heat, the black surfaces. So next topic, let us move on to the radiation exchange between opaque, diffuse, gray surfaces in an enclosure. Suppose there is an enclosure. There is the enclosure which consists of n surfaces. Say surface 1, surface 2, surface 3, surface J, surface N, something like this one. So there is the n surfaces, and these all n surfaces are opaque, diffuse, and gray. So what we have seen, we have drawn an schematic for an enclosure which consists of n such kind of surfaces. So before analysis, let us make few assumptions. What we are going to simplification that we are going to use. So what is the different assumptions? The first of all, we have assumed that each of the surfaces is isothermal. That means all the surfaces are maintained at constant temperature. Say this is the surface 1 is maintained at Ti, the surface J is maintained at Tj, the surface I is maintained at Ti, the surface 1 is maintained at T1, the surface N is maintained at Tn. That means all the surfaces are isothermal. Also, all the surfaces is characterized by uniform radiosity as well as uniform irradiation. That means for each surfaces, it has the constant radiosity Gi and constant irradiation Gi, or Gj, Jj, or Jn, Gn. So also the surfaces is assumed, each surfaces is assumed to be the diffuse. What does it mean? Diffuse means what? All the surfaces, say Ji surfaces is assumed as to be diffuse. That means the emissivity, reflectivity, and objectivity, these all will be independent of direction. Also the surfaces is assumed to be gray. That means the radiation will be independent of wavelength. Also the medium, that is these all medium that is assumed to be non-participating. They are not taking participation in the radiation phenomena. So under these all assumptions, we have learned one Kirchhoff's law. That means here with these all assumptions, we can apply the Kirchhoff's law. And Kirchhoff's law says that the epsilon should be equal to alpha. Epsilon will be equal to alpha, means emissivity of a surface will be equal to the absorptivity of the surface. So the in the our analysis, our present objective will be the objective of this analysis will be to determine the heat fluxes of the each surfaces and the temperature also. So let us consider one surface. Say one surface I we have considered, and this will form a system. So this is the system boundary. Now let us analyze what are the energy interaction that is taking place through the boundary on this system. So this is the surface I. Let us we are interested to determine the net rate of the radiation that is leaving from the surface I. At what net rate the radiation is coming out from the surfaces, or so it is the same effect. That means the net rate that is coming out, that is leaving from the surface I, will be the same as the rate of energy that we need to supply to the this surface in order to have the constant temperature. से ये surface I है, अगर इसमें कुछ इंट्रैक्शन, सपोज इसमें से कुछ एनर्जी छोड़ के बाहर जा रहा है, तो इस सरफेस का टेम्परेचर चेंज हो जाएगा. अब अगर इस सरफेस आई का टेम्परेचर कांस्टेंट रखना है, तो जितना एनर्जी इसे छोड़ के जा रहा है, सरफेस को लीव कर रहा है, उतना ही इसमें एंटर करना चाहिए. सो दैट एनर्जी से लेट अस से इज QI. That energy is QI. That means QI is the radiation in order to maintain the temperature constant of the surface I. So ये कितना होगा, जितना एनर्जी बाहर जा रहा है उतना ही ये कितना हो जाएगा, उतना एनर्जी हमें सप्लाई करने की जरूरत पड़ेगी. तो कितना एनर्जी जा रहा है, इस सरफेस के पास GI आ रहा है और टोटल GI छोड़ के सरफेस से जा रहा है, तो नेट एनर्जी कितना इसमें चेंजेज आया, GI माइनस GI, उतना एनर्जी इसमें सरफेस में कम हो रहा है, तो उतना बराबर ऑफ सरफेस एनर्जी हमें सप्लाई करने की जरूरत पड़ेगी. सो द QI विल बिकम GI AI दैट इज लिविंग, और कितना आ रहा है, जितना आ रहा है सरफेस के पास इरेडिएशन के थ्रू GI एंड AI. So QI will become AI, अगर हम कॉमन ले लेते हैं तो JI माइनस GI. So हम GI के बराबर एक हमने GI का डिफिनेशन भी पढ़ा था. GI क्या कहता है, GI is nothing but GI is the radiosity which is the summation of emissive power and the part of reflected part of the irradiation. So टोटल इरेडिएशन कितना है, GI AI. अब इसमें से सरफेस आई के द्वारा इतना पार्ट रो आई GI AI रिफ्लेक्ट कर दिया गया, अल्फा ई GI AI एब्जॉर्ब कर लिया गया. सो इसका कितना पार्ट एब्जॉर्ब किया गया है, रो आई GI, और कितना पार्ट जा रहा है वापस, EI AI. सो टोटली जो सरफेस से लीव आउट हो रहा है वो इमिशन के करस्पॉन्डिंग और रिफ्लेक्शन के करस्पॉन्डिंग, दोनों का अगर सम टोटल करेंगे then that will give the radiosity. That is the we have learned the definition of radiosity. So instead of radiosity हमने ये definition substitute कर दिया. So EI रो आई GI substitute किया गया. अब इसको हमने सिंप्लीफाई किया तो 1 माइनस रो आई GI कन्वर्ट हो गया. चूंकि ये ओपेक सरफेस है, हमने अजम्पशन मान रखा है ओपेक सरफेस. व्हाट डू यू मीन बाय ओपेक सरफेस, द सरफेस फॉर व्हिच द ट्रांसमिसिविटी इज 0. मींस व्हाट, ट्रांसमिसिविटी जैसे ही 0 हो गया, जैसे ही ट्रांसमिसिविटी 0 हो गया, तो अल्फा प्लस रो प्लस टाउ शुड बी 1, देयरफॉर रो प्लस अल्फा शुड बी 1, therefore 1 minus rho can be written as a alpha. So instead of 1 minus rho I, we get replaced by the alpha I. So from the Kirchhoff's law, we know that alpha I will be equal to epsilon I. So the Qi becomes the Ai into Ei minus epsilon I into Gi. So now what is the Ei? This is the emissive power of the real surface that can be written in terms of epsilon times emissive power of the black body. That is the from the definition of emissivity we can write it, and we can have by taking we can have the this epsilon out, we can take this epsilon out of the bracket, so it will become ai epsilon I evi minus gi. Now let us rewrite this this definition of radiosity, which states that gi is equal to ei plus rho I gi. For opaque, the rho I will be replaced by the 1 plus alpha I, and from the Kirchhoff's law, alpha I will be replaced by the epsilon I. Therefore, this Ji is become the function of epsilon and EBI and GI. Now, GI can be taken out at the one sided, and another term we can replace it on the, we can place it on the another side. So instead of GI, that is replaced by the term, combination of term, which is a function of GI, epsilon I and EBI. Now by the rearrangement, we can write and simplify, we can get an expression like Qi is equal to, see, after the rearrangement and taking out the expression, we can write down one expression, general expression that we got it as a Qi is EBI minus Ji upon 1 minus epsilon I upon Ai epsilon I. So if we can represent in the form of network, then this is the representing EBI minus JI is, means QI means the radiation that is coming out from the surface I, EBI means the corresponding emissive power of the black body, which is maintained at the same temperature as of the surface I. Gi is the radiosity of the surface I. So this difference EVI minus GI will be the driving potential, and this terminology in the denominator 1 minus epsilon I AI and epsilon I will be surface radiative resistance. So we can draw a equivalent radiation circuit, that means which will say there will be the potential EVI and GI, and this will be the equivalent, the surface resistance. What does it signify? It is very useful result that we have got here. How? That means there is the one radiosity of the surface I that can be replaced, or that can be connected to equivalent the body, the radiation that is the total radiation that is coming out from the surface I, that is coming out the surface I is GI radiosity. The same radiosity can be understood as the radiation is not coming from the real surface I, but it is coming out from the an equivalent or hypothetical black body which is maintained at the temperature same as of surface I, and with resistance, surface resistance 1 minus epsilon I upon epsilon I AI. मतलब क्या हो गया कि जो रेडियोसिटी GI से हम लोग रेडिएशन कर जो हम लोग सीख रहे हैं वो रेडियोसिटी के साथ नहीं आ रहा है, लेकिन इस रेडियोसिटी को हम इक्विवेलेंट इन टर्म्स ऑफ ब्लैक बॉडी से मान सकते हैं कि वो रेडिएशन ब्लैक बॉडी से आ रहा है विथ एडिशनल सरफेस रेसिस्टेंस। मतलब एक ब्लैक बॉडी जो टेम्परेचर GI के आई सरफेस के बराबर पे मेंटेन हो रहा है, और एक हम सरफेस रेसिस्टेंस 1 माइनस एप्सिलॉन आई अपॉन एप्सिलॉन आई AI जोड़ देते हैं, तो ये जो रेडिएशन होगा ब्लैक बॉडी से विथ दिस सरफेस रेसिस्टेंस, वो इक्विवेलेंट टू किसके बराबर हो जाएगा? रेडियोसिटी फ्रॉम द रियल सरफेस आई, रियल सरफेस आई के बराबर होगा। सो अगर सपोज अगर एक सरफेसेस, इसमें से जो एक सरफेस है वो बहुत लार्ज हो जाए, सपोज द सरफेस हमारा रेडिएशन जिससे हो रहा है दैट इज लार्ज एंड वेरी वेरी लार्ज, अगर इनक्लोजर में जैसे एन सरफेसेस था उसमें से एक सरफेसेस का बहुत ही लार्ज साइज हो रिलेटिव टू अदर, दैट मीन्स क्या होगा? ए एरिया टेंस टू इनफाइनाइट, दैट मीन्स दिस होल टर्मिनोलॉजी विल टेंस टू जीरो। जब ये जीरो हो जाएगा तो ये जो 1 माइनस एप्सिलॉन आई शुड बी इक्वल टू जीरो, दैट मीन्स एप्सिलॉन आई विल बिकम 1 माइनस एप्सिलॉन आई विल बी इज इक्वल टेंस टू जीरो, मीन्स क्या हो गया? एप्सिलॉन आई टेंस टू 1, means emissivity of a real surface I is tending to 1 when the surface area of that surface tends to infinite, that means जब surface area बहुत बड़ा कर देते हैं तो एक real surface किसकी तरफ मूव करना शुरू कर देता है? ब्लैक बॉडी की तरफ बिहेव करना शुरू कर देगा। इन दैट केस जो भी GI होगा, रेडियोसिटी होगा, वो ब्लैक बॉडी इमिशन के बराबर, इमिसिविटी के बराबर होगा। That means we can make a statement that a surface which is large relative to all other surfaces under consideration. Under consideration means what? We have considered a cavity which consists of different number, many number of surfaces, can be treated as if it were a black body. मतलब large surfaces हुआ तो इसको black body की तरह हम लोग treat कर सकते हैं। So today we will stop here, and in the next class we will learn about the radiation exchange between the surfaces. So thank you for listening me. Please stay home, stay safe, keep learning. Thank you very much. So we are going to stop here. Please go through all the lecture. Thank you.